Check one. Check one. Right. Good evening, everybody. Today, we are going to do a new type of class for 2024 O-level batch students. Enemy, not the next week O-level batch students. The following year. The following year, in the sense, most of the time it will be next year by about March, April, that period. That batch students, a special online class we are going to start from today. Before I start, y'all tell me, is all the DOs perfect? Groups are open. We'll use the group for today because YouTube also it's live streaming. Zoom also live streaming. Okay, send the message to Zoom also as well as through WhatsApp group. Grade 11 groups are open. Dingala tell me. Zoom people also. YouTube people also. Is everything working clear? Hurry. Hurry, ne? All okay. All okay. Hurry. Me time is this time from 7:30 p.m. to Saturday 7:30 p.m. to 10 p.m. That's your time slot. New online class. Nothing. We can name it as interactive class or any online class. Online session. Hari. For 2024 O-level batch student. Now listen. Now already 2023 O-level batch. They are almost done. Yeah, lot of maximum things that can be done from my end done. Hari, maximum is done. Oh, day after tomorrow, they are sitting for the O-level final exam also. So for them, everything is done. So next, the full focus is on y'all. 100% focus is on y'all. Now they are done. Next, the 100%, 100, nothing, 200% focus is on y'all. The spotlight is on your batch. From my end, I'll give the best I can. Hari, another about 1 year of run is there. From my end, I'll give the best I can. From your end, I need 200% of input. Don't keep anything to work at the end. From the beginning, from day one itself, start working. Everything that you study, that day itself, put to the mind and go. Ehema, you study and go. Hari. Accordingly, until now, our online sessions was a live stream of Candy physical class. Until now, we did a live stream of Candy physical class as the online class for 2024 level batch. But from today onwards, I just wanted to experiment and see. Right? I wanted to experiment and see to make it more interactive, because when it comes to physical class live stream, our interactions are much lesser. Those who join to that class, they know interactions between us are much lesser. But if it is separate online, today I'll allow you all to unmute also. We'll slowly go to that step. So if it is separate online, it's got only me and y'all are there. So with that, we can move in a more better way. We can finish the things and go. So from today onwards, our online session is splitting. Candy physical class will go as physical class. That live stream will also be given. Hari, Candy physical class live also will be given, because some people on Saturday night, they have classes. No? You can join that, but that is a Candy physical class live stream. But Saturday is a separate online day, 30 p.m. to 10 p.m. It's a separate online interactive class, separately for the online student. So things are going to proceed. So today is a first day class already until mixtures we have done. Mixtures our 2 days are remaining. Our past paper questions are there. We were doing 1980s past papers and all. Those question discussion part is there. Salt extraction chudi part is there. For those two, tomorrow, Sunday and next Sunday join. With that, that mixtures will be over. After that, you can continue. Whether if you want to continue on Saturday, you can continue on Saturday. Others, if you want to continue on Sunday, you can continue and go. Hurry. So after that, everything is splitting up. Saturday people on Saturday, Sunday people on Sunday. Okay. Ehenang, we will unmute now. Lot of time now. I am only talking. Good evening.
Good evening, sir.
Good evening, sir.
Very good evening.
Good evening, sir.
Good evening. Hari. Zoom people, YouTube people la upset. YouTube people still can't unmute. Hari, come on, ne? So, however, later it will proceed only through Zoom. So, Zoom people can unmute, ask questions, ask doubts. Himai, it's going to go ahead. Okay. For now, I'll mute you all. We'll start the session. So, when there are sections coming to talk, we will talk. That way, we are going to proceed. That way, we are going to proceed. Hurry. I hope all of you have the tute with y'all. Waves lesson tute with y'all. Himai need have the tute?
Yes, sir.
Yes, sir.
Yes. Have the tute, no? Hurry. Take waves tute now. Take waves tute. Waves tute. At
Sir,
least
I
have the
don't find the
PDF with
tute,
y'all.
sir.
Those who joined at the last moment, at least have the PDF with y'all. Waves tube. At
Sir,
least
I
have the
don't
PDF.
have the PDF format also.
PDF format. Can someone put it to the group? PDF. I already sent it today morning as well as evening. Okay. All right. Have the PDF at least with y'all. Hurry. Hurry. Right. Wave section. Waves. Unit 4. Waves and their application. Part important section. Waves and the application. Part important. IE. Until now, from grade 6 to until today, you have never learned about wave section. In physics, so many things you all learned about motion. You all have learned velocity, displacement, velocity, time. A motion part you have learned about heat, thermal physics. You have learned about wave section, oscillation part. Not at all touch. Therefore, this lesson is slightly different, Lamai. It's slightly different to the physics that you have learned so far. Habai patta lazy. More lazy. Sariyana mar easy section. Not hard, but something new. Hinda from beginning until the end, focus, very carefully listen, put it to the mind. Simple section, but very new section. In case while I am talking, if you get up and go to the bathroom and come, everything finish. You miss a small part, lot of part after that will get missed. Haridar, okay. So, however, try to stay throughout the session. Don't just go to WhatsApp. Don't just go to Instagram. Don't go to do those things. Focus, listen. Now itself we study. Now itself we put it to the mind. Simple section, but new section. Okay. Hurry. Waves. Waves. Waves and the application is the heading. Waves. What is a wave? Listen very, very carefully. What is a wave? Listen. What is a wave? It's a disturbance. What is a wave? It's a disturbance. What does the wave do? It transmits energy from one place to another. What does a wave do? It transmits energy from one place to another. So everything together, what is a wave? A wave is a disturbance that transmit energy from one place to another. Repeat with me. What is a wave? A wave is a disturbance that transmit energy from one place to another. Again, tell me what's a wave? A wave is a disturbance. Transmit energy from one place to another. Now, sometimes when you are small, you wondered, no? How energy flows, how energy goes from one place to another. Now my sound, it's a sound wave. Sound is a energy. How my sound goes until you. First of all, from me, sound should go until the mic. How is this sound going to the mic? As sound waves. If you take light is an energy. How light is spreading around our room, classroom, whatever the place you are staying in. How this light is spreading from the bulb as light waves. It's a type of electromagnetic waves. I'll teach about it. As light waves, this light is spreading around. Heat, these days very hot, no? Heat. How is this heat spreading around? As heat waves. So remember, energy is transmitted from one place to another by wave. So altogether, again, what is a wave? A wave is a disturbance. What does it do? Transmit energy from one place to another. Again, one more time, tell louder. What is a wave? A wave is a disturbance that transmit energy from one place to another. Again, one more time, unmute and tell me, what is a wave? What is a wave?
Wave is a
wave
disturbance which
that
transmits
transmit energy from
one
one
place.
place to another.
One place to another. Clear? 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 Clear?
Yes, sir.
Yes, sir.
Right. Perfect. Perfect. Now listen. Now listen. A wave will transmit energy from one place to another. Wave transmit energy from one place to another. Now, for example, let's take sound. I am here. I am here. This is King Saya. I am here. I am talking. I am talking. I am sound. That sound travels as sound wave. Here we have atmosphere. Through this atmosphere, sound is traveling as sound wave. In this atmosphere, there are particles. Correct? No? There are particles in it. Atmosphere made of air. Air has particles in it. Remember, in a wave, only the energy is transmitted from one place to another. Will the particles move from one place to another? No. The particle which is here will remain here. Might be it will show a little bit of vibration, but particle won't go from one place to another. That's a very important point. Only the wave travels from one place to another. That means energy is transmitted from one place to another. Particles are not transmitted from one place to another. Whatever the particle here remains here at the end of the day. Whatever the particle here remains here at the end of the day. This particle remains here. Might be it will show a little bit of vibration. It might move up and down. Happy. It will come back to its original position and stay there. The particle won't move from one place to another. Put that to the mind. Huh? Particle won't take the energy. Okay, give me some energy. I'll walk from here to there. A particle won't go. Particles will remain at the same place. Only the energy is transmitted. So remember, through a wave, what is transmitted? Energy. What is not transmitted from one place to another? Particles. Put it to the mind. Energy is transmitted from one place to another. Particles are not transmitted from one place to another. Okay. Clear? Clear?
Yes, sir.
Now I'm going to ask some questions. Who is going to be our first volunteer? Raise the hand. Hima bhai when deba. Who is going to be our first volunteer? Raise the hand. Whatever I taught only, I'm going to ask the question. Hima nathang, I'll take the volunteer now. We have very good volunteer. Two people are there. Three people are there. Then we'll go for a selection. No. First, who raised the hand? Hamir Sharif. Yeah. Can you hear me?
Sir, I'm not Hamid Sharif, I'm Azkia, sir. It's my
Right, Askia. Right. Okay. Askia, right. Can you unmute?
yes, sir.
Right. So, what is your school? Tell me.
Al Azhar National School,
You're
sir.
from Kandy.
No, sir, Tihari.
Right. Some question. Very, very small question. You are the first volunteer. Very, very small question. Tell me then. What is a wave?
A wave is a disturbance that transmits from one place to another.
What is transmitted through a wave?
Energy,
Energy. What is not transmitted through a wave?
particles.
Particles. Perfect. Thank you.
Okay, sir.
Right. Ehenam lamai, take your tute now. Take your tute. Now, interactive class is that time. Hima, I will at once catch a person, ask for questions. These things doesn't even happen in sometimes in physical classes. Now only we have just started in physical classes, catching people and asking questions. So here suddenly I'll ask a person, okay, unmute and talk. Throughout the session, you should interact. That's the main plan. That is what I am actually experimenting. It's not just like going to be like lectures. I'm just experimenting whether through online class from your end can we get maximum input more than the teacher's input. That's the experiment I'm trying to do from this interactive class. Correct? Take your tute. Take your tute. Waves and their application. Now, those who don't have the tute, take your writing book. Whatever I tell, write it in the writing book. So after that, you can have a printout and then write those things. No. What is a wave? Right there. Right there. A wave is a disturbance. A wave is a disturbance. A wave is a disturbance. A wave is a disturbance that transmit energy, that transmit energy, that transmit energy from one place to another, from one place to another, from one place to another, without the propagation of particles. 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 Again, check and see. What is a wave? A wave is a disturbance that transmit energy from one place to another without the propagation of particles. Okay. Next point is also given there. Waves propagate energy from one place to another without propagation of particles. If you want, highlight it and keep. You can highlight it and keep. Hurry. Now going deeper. Now going deeper. Drop your pens. Eyes on the screen, ears on the speakers. Listen very carefully. Listen very, very carefully. Yeah? Now listen very carefully. Right. Because you all know at the end what I'll do. I'll ask questions. Hey, Hinda, listen very, very carefully. Right. Wave. We'll make it plural. Waves. You all know already what is a wave. A wave is a disturbance that transmits energy from one place to another. That definition you all know. Now listen. The waves are mainly divided into two. Waves are mainly divided into two. What are the two? One, mechanical wave. Mechanical wave. On the other hand, electromagnetic wave. Electromagnetic wave. One shot, put it to the mind. Waves are mainly divided into two. What are the two? Mechanical waves and electromagnetic wave. First, what is a mechanical wave? What is a mechanical wave? Listen, will you? The mechanical waves require a medium to transmit, nathang propagate. Mechanical waves require a medium to propagate. They need a medium. They require a medium. Mechanical waves, there you go. Require a medium. Require a medium. Require a medium kiyanne. Single medium, Tamil medium, English. No, not that medium. What is medium? A substance. Now, if you take water, water is a medium. Air. Air is a medium. It's a gaseous medium. A metal block. It's a medium. It's a solid medium. Those are all mediums. Through that, if you can send something, you can send something. So, medium is a substance through which you can send something. Mechanical waves require a medium. So, then y'all tell me, can mechanical waves travel in space? No. Why? In space, do we have a medium there? No, any medium. It's just empty there. So at empty space, mechanical waves can't propagate. Mechanical waves need a medium to propagate. Without a medium, they can't travel. They require a medium. On the other hand, electromagnetic wave. Electromagnetic wave do not require medium. Do not, there you go, require a medium. These people do not require a medium. That means they can travel in space. They don't need a medium. Listen to the words I'm using. Do not require. Require a medium. That means medium is not a requirement. In case if there is a medium, still they can propagate. That is what you mean by do not require. They don't need a medium, but in case if there is a medium, still they can propagate. So medium is not a must for electromagnetic wave. If I tell it in more simpler term, what is this require means? Now let's take you are going for a interview after your O-level exam. You are going for a job interview. In the interview, they are telling A for science is not a requirement. Just imagine, let's take in the job interview, they are telling A for science is not a requirement. But fortunately, you have a A. Already you have a A. That doesn't affect. No? A for science is not a requirement. In case if you have A also, you can go for the job. If you don't have A also, you can go for the job. That is what you mean. A for science is not a requirement. You have A, you can go for the job. If you don't have A, still you can go for the job. This also makes that same meaning. Do not require a medium. If there is no medium, electromagnetic waves can propagate. If there is a medium, still electromagnetic waves can propagate. So understand the meaning there. Waves are divided into mechanical waves and electromagnetic wave. Mechanical waves require a medium. They need a medium. Without a medium, they can't propagate. Electromagnetic waves do not require a medium. If they don't have a medium also, they can propagate. If they have a medium also, they can propagate. Okay. Now going deeper. Now going deeper. Now going deeper. Mechanical waves. Furthermore divided into two. Mechanical waves are furthermore divided into two. What are the two? One, transverse wave. Transverse wave. The other, longitudinal wave. Longitudinal wave. So there are two types of mechanical waves, transverse wave and longitudinal wave. What are the two types of mechanical wave? Transverse wave and longitudinal wave. Don't worry. We will talk very deeper about transverse wave and longitudinal wave in this lesson. I'll just give you all the examples and key examples for transverse wave. Water wave. Water wave. Water wave kiyanne. The wave that the water makes. Water wave. It's a transverse wave. Motion of a string of a guitar. A guitar has the string. No? When you pluck it, it shows a certain motion. No? This guitar. This is a new type of guitar, Lama. Only one string is there. Imagine like that. It's a new type of guitar. Only one string. Single string guitar. Single string guitar. So how does the string vibrate now? When you pluck the string is like this, isn't it? You pluck string moves like not string. It's a transverse wave. It's a transverse wave. So motion of a string of a guitar. Motion of string of guitar. Not only guitar, violin, any string instrument you can write. String of guitar. They are all transverse wave. On the other hand, longitudinal wave. What are the examples for longitudinal waves? What are the examples for longitudinal wave? When you tell longitudinal wave, what should come into your mind first? Sound wave. What should come into your mind first? Sound wave. Longitudinal wave. What should come into the mind first? Sound wave. Okay. On the other hand, electromagnetic wave, also called as electromagnetic radiation. What are the examples? I will write all the examples for electromagnetic waves. Gamma rays. Gamma rays. Gamma rays, electromagnetic wave. X-ray, electromagnetic wave. Ultraviolet radiation or ultraviolet radiation, UV rays. Ultraviolet radiation. Visible light. Visible light. Infrared radiation. Microwave. Microwave. Radio wave. Radio wave. All these are electromagnetic wave or electromagnetic radiation. Everything again from the beginning. Again from the beginning. Again from the beginning. Waves. Waves are mainly divided into two. What are the two? Mechanical waves, electromagnetic waves. Mechanical waves require a medium. Electromagnetic wave do not require a medium. Mechanical waves are again divided into two. Transverse wave, longitudinal wave. Now, transverse wave also then require a medium because it comes under the mechanical wave. No? So, it also need a medium. Longitudinal waves also need a medium because it also comes under mechanical wave. So, transverse wave, longitudinal wave. Transverse wave, what are the examples? Water wave, motion of a guitar string. Longitudinal wave, what's the best example? Sound wave. Now, sound wave, sound, it needs a medium. Sound needs a medium. Without medium, sound can't travel. Now, let's take you and your friend are going to the space. Hari, Mara, lucky people, you both are going to the space. You got a trip to space. You and your friend both are going to space. In the space, do you have a medium? No. You don't have a medium in space. Let's say your friend is this side. You call him. Hey. No. Hello, won't answer anything. Why? He can't hear. No? Sound can't travel through space. Sound is medium to travel. In the space you go and call him, he won't hear. He won't listen. He can't hear. Now, Earth also, when you him, he can't hear. No, he stays if he can't hear. Think of going to the space. However, can't hear. Aye, sound can't travel in. Okay. So remember, sound needs a medium to travel. No medium, no sound. No medium, no sound. On the other hand, electromagnetic wave. Electromagnetic wave do not require a medium. What are the examples for electromagnetic waves? Gamma rays, X-ray, ultraviolet radiation, visible light, infrared radiation, microwave, radio. Okay, again one more time. Waves are mainly divided into two. Mechanical wave, electromagnetic wave. Mechanical wave require a medium. Electromagnetic wave do not require a medium. Mechanical wave again divided into two. Transverse wave and longitudinal wave. Transverse wave example, water waves, string of the guitar string, motion of a guitar string. Longitudinal wave, best example, sound wave. Electromagnetic wave, what are the examples? Gamma ray, X-ray, ultraviolet radiation, visible light, infrared radiation, microwave, radio. Sorry. Okay. Okay. Right. Now some question from this section. No. Before going to the question, we'll first write it. No? I'll ask the question. In your tute lamai, there's a big space given like this. No? A big space given. I want you all to write this in that space. Meanwhile, put it to the mind. I'll ask some questions. Write it in that space. Meanwhile, put it to the mind. Exactly 5 minutes I'll give you. Write it. I'll make it a little bigger. First write the upper part, and then I'll take it to the bottom. Shall we move down? Once done, tell me done, eh? Done. Go to the last part there. Finish this part fully. Okay, no? Right. So now we all have a basic idea about what is this wave. Now go into the question part. Who is going to volunteer? Who raised the hand first? Zainab. Zainab Bilyas.
Yes, sir.
Yes. Good evening.
Good evening. Good evening, sir.
You're from?
Akurana.
You're from Akurana, right? Zainab, then you tell me. What are the main two types of waves?
Mechanical waves and electromagnetic waves.
Electromagnetic waves. Very good. Mechanical waves, they require a
Medium to propagate.
medium to propagate. Electromagnetic wave, they
Do not require a medium to propagate.
medium to propagate. Mechanical waves are again divided into two. What are the two types?
Transverse wave and longitudinal wave.
Right. Transverse wave, tell me one example enough.
Water wave.
Right. Longitudinal wave, tell me the best example, you know.
Sound wave.
Sound wave. Electromagnetic wave, tell me about two examples.
Gamma rays and X-rays.
Yeah, perfect. Thank you.
Thank you, sir.
Okay. Ehenang lamai, now take next page. Next page, under that. Under this box. Mechanical wave. Mechanical wave. Mechanical wave. Wave that need a medium to propagate. Correct? No? Mechanical wave need example. Tell me the examples. Mechanical waves. Appa. Now what are the examples for mechanical wave? Don't think a
Water
lot,
wave.
Lama.
Water wave.
Water wave. Sound wave. Motion of a string.
Hurry. See, all these waves are coming under mechanical waves. All of them are coming under mechanical waves. Then all of them are examples for mechanical wave. Right about to water wave, sound wave. Right about to water wave, sound wave. Water wave, sound. That's enough. Water wave, sound wave. Next, mechanical waves are divided into two. What are the two?
Transverse wave and longitudinal wave.
Right up. Transverse wave, longitudinal wave. Transverse wave, longitudinal. Right. Now we'll go deeper about transverse wave and deeper about longitudinal waves. First, go to transverse wave. Again, drop your pens. Eyes on the screen, ears on the speaker, nothing else. Listen very carefully. Simple things, but don't misunderstand, don't do unnecessary things and leave the thing. Hurry, from the beginning until the end, listen. Transverse wave. wave comes under mechanical wave. That means transverse wave need a medium to travel. That we already know. Transverse wave need a medium to travel. In the medium, what you have? You have particles. You take solid medium, particles are there. Liquid medium, particles are there. Gaseous medium, particles are there. Any medium has particles. So there are particles. These are the particles in the medium. These are the particles in the medium. Now let's say what wave? Wave moves in, let's take this direction. This is the direction of motion of the wave. Listen very carefully. This is the direction of motion of the wave. That's the direction of motion of the wave. There you go. That's the direction of motion of the wave. Wave is traveling in that direction. From that point, this point to there, wave is traveling. Wave is traveling in that direction. Wave is traveling in that direction. This is the direction of motion of wave. Direction of motion of wave. What particles do? Particles show a little bit of a movement. How the particles are going to move? Particles move this up and down. Wave is traveling in direction. Particles are moving up and down. Look very carefully. Wave is traveling that direction. Particles are moving up and down. Wave that direction. Particles are moving up and down. If you carefully see, can you see direction? Follow my carefully.
Sorry, yeah.
Particle. What do you mean by perpendicular, Lamai? Can't hear. Now can hear. Can. And motion. No any lagging. Huh? No any lagging. Hari. Now all right. Hima damai. Hari. Ah. I'll, I'll explain. This is the direction. That direction. This is the direction of wave. Again went. This is dropping. Now see. Check one. Check one. Hari. Now see. Now see. I go near the screen. I go near the screen. Again listen. The motion of the wave. Now can't hear. Is there anything there? Shall I explain? එහෙම වෙන්න බෑනේ නේද? Yeah, might be signal issue from there. Hurry, from this side, can you hear properly? Can. Yeah, might be there are, I'll explain that. There might be electromagnetic waves there. That also has electromagnetic wave, my transistor has electromagnetic waves. Hurry, that might be the reason. Till now, voice is talking. Hinang, give me a second. Now should be okay. Hurry. Now again. Now okay. ඒකනේ. Hurry. Right. Transverse wave. Transverse wave. Listen, eh? This is the direction of motion of the wave. Wave is traveling in that direction. Wave is going in that direction. It's the direction of motion of the wave. Wave is traveling in that direction. There are particles. What is happening to the particles? Particles are moving up and down like this. Wave is traveling in this direction. Particles are moving up and down. That means, can you see particles motion is perpendicular to the direction of motion of the wave? See, particle motion is perpendicular. What do you mean by perpendicular? 90 degrees. Particle motion makes 90 degrees perpendicular to the direction of motion of the wave. All the particles are moving in that same way. See, particle motion perpendicular. Particle motion perpendicular, the direction of motion of the wave. There you go. Particle motion perpendicular. Particles motion perpendicular to the direction of motion of wave. Particle motion perpendicular to the direction of motion of wave. Such a wave is transverse wave. Then what is transverse wave? The direction of motion of wave is perpendicular to the direction of motion of particles. We call that wave as transverse wave. What are that? If direction of motion of wave, this is the direction of motion of wave. Direction of motion of wave is perpendicular to the direction of motion of particle. That wave is a transverse wave. Then what's the key word in transverse wave? What's the key word? Perpendicular. Key word is perpendicular. Perpendicular. Particle motion is perpendicular to the direction of motion of the wave. Hurry. Again listen one more time. Again listen one more time. Transverse wave. Particles are there. Particles are there. Let's take wave is traveling from here to there. Wave is traveling from there to there. This is the direction of motion of wave. That's the direction of motion of wave. That's the direction of motion of wave. Wave is going from here to there. When the wave is traveling from here to there, what happens to the particles? Like mental fools, they move up and down. Just like fools, okay, they go up and down. They go up and down. They go up and down. Particles move up and down. Particles move up and down. So if you carefully look, particles motion is perpendicular to the direction of motion of the wave. Particles motion is perpendicular to the direction of motion of wave. Such a wave is transverse wave. Don't misunderstand and think particles are moving from one place to another. Tell me, is the particle moving from one place to another? No. Particles are in their original position, just going up and down. HRI. They are fixed to the original position. They are moving up and down. Don't think the particles are moving totally from one place to another. No, they are not moving. Just they are moving up and down. Okay. Understood transverse wave. Then what is transverse wave? If the particle motion is perpendicular to the direction of motion of wave, wave is transverse wave. Again, one more time. What is transverse wave? If particle motion is perpendicular to the direction of motion of wave. Transverse. Don't memorize. Understand it logically. Particles are perpendicularly moving to the direction of motion of wave. Okay. I'll come to the vibration part. Don't get confused with vibration. I'll come to the vibration part. This is not vibration. This is oscillation of the particles. You can't consider it as a vibration. It's an oscillation of the particle. I'll come to the vibration part in longitudinal wave. Okay. In your tute, under transverse wave, write down. Under transverse wave, write down. If the motion of particles, if the motion of particles, if the motion of particles, if the motion of particles are perpendicular, are perpendicular to the direction of motion of wave, to the direction of motion of wave, to the direction of motion of wave, it is transverse wave. It is transverse wave. It is transverse wave. Unmute and tell me the examples for transverse waves.
Water wave,
Water wave,
String of a
motion
guitar.
of guitar.
string of a guitar.
Perfect. Perfect. Example, water waves and direction of motion of a string of a guitar. Correct? No? If you take string of a guitar, string of a guitar string is like this. How do you pluck it? You pluck it this way, you know, isn't it? Guitar string is like this. Guitar string is like that. You are going to pluck it this way. This is how you pluck it. This is how you pluck it. Guitar string is like that. You pluck it this way. And do you pluck it this way? Mehima the guitar down. Do you play the guitar that way? No. You pluck it this way. See? Motion of the particles are perpendicular to the direction of the motion of wave. Okay. Write down example. Water wave. Water wave. Water wave. Come on. Motion of a guitar string. 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 Under that a box is given. No, before that, one more special point. One more special point. Remember, these transverse waves propagate only through surfaces of solids and surfaces of liquids, and of course through strings and wires. Does it propagate through gases? No. Transverse wave only propagates through the surfaces of solids and surfaces of liquids. Correct? No. Water wave propagates through the surface of liquid, and water is a liquid. Through the surface of liquid only water waves propagate. So transverse wave only propagates through surfaces of solids and surfaces of liquids, also through strings and wires. Does it propagate through gases? No. Transverse wave do not propagate through gases. Put it to the mind. So that point is given. That point is given. Propagate along surfaces of solids and liquids, or strings and wires. Under that, a box is given. I want you all to draw this in that box. Where? This one. Draw it in that box. Mark this as motion of particles. Draw. Meanwhile, if you have any doubts, raise the hand. I'll allow you to unmute and you can ask. Anybody with doubts? Or send it to the chat box. So does wave cause a loss of energy? Sometimes yes. I will explain when and where loss of energy happens. So can you allow AI companion? No. AI companion is switched off. So can you say the definition of transverse wave again? Definition. If the motion of particles is perpendicular, if the motion of particles is perpendicular to the direction of motion of wave, to the direction of motion of wave, the direction of motion of wave, it is transverse wave. So transverse waves can also travel through vacuums too, right? No. Transverse wave is a type of mechanical wave. Mechanical waves need a medium to travel. Without a medium, they can't travel. That means vacuum, there is no medium. It can't travel. Do you do London syllabus? No. Recording for this session. It is live streamed through YouTube. So after the session, it will be there in the YouTube. This will come for the structured questions. Most of the time, waves lesson come to structured. Yes. Okay. Done. Once done, lamai, tell me done. Done. Sorry. Right. Now actually lamai, we can learn about this wave motion by using a device called Slinky. What key? Slinky. Using Slinky, you can learn about wave motions. Using Slinky, you can learn about wave motion. I have a Slinky, I'll show you all. Now this is a Slinky. See? It's fun. Right? This is a Slinky. Right? It's a weak spring-like thing. It's a big spring-like thing. Spring-like thing, no, it's a spring only. See? It's a Slinky. Now using a Slinky, you can learn about wave motion. We have small practical here also. I will try to do it, showing you all. And this is a Slinky. We can learn about transverse wave using a Slinky. Just think my hand is a table. Okay, my hand is the table. Right? My hand is the table. So Slinky is on the table. Slinky is on the table. So spring, Slinky is on the table. Now transverse wave. This is transverse wave. That is transverse wave. See? This is a transverse wave. See, wave is moving from this finger to that finger. Wave is going from here to there. See, wave is from here to there. Wave is from here to there. What about the particles? Particles are moving up and down. Particles are moving up and down. See, particles are moving up and down. Particles motion is up and down. Okay. Is the particles totally moving from one place to another? I will put a mark and show you all. Check, tell me, is the particle totally moving from one place to another? Now somewhere here, we'll put a mark. I'll put a white paper and keep. I have put a mark there. Can see the mark? That white paper is the mark. That white paper is the mark. Check, huh? Check whether the white paper is moving from one place to another or not. Got removed. Hey, Harianne, I'll put a rubber band. Right. Rubber band is a fixed point. Sorry. Rubber band is a fixed point. To some extent, all of you can see the rubber band. So rubber band is the fixed point there. Now what I'm going to do, I'm going to pass a wave. Can see, no? Yeah, can see the rubber band. I'm going to pass the wave. Check whether the rubber band is moving totally from one place to another, no, or not. See, wave is going. Rubber band is at the same place, no? See very carefully. See very carefully. I'll put a mark on the board. This is where rubber band is. That's the position of rubber band. I send the wave. Rubber band is in the same place. Rubber band is in the same place. See? Rubber band is in the same place. Rubber band is in the same place. So that means in a transverse wave, see, wave is traveling, particles are moving perpendicularly. Is the particle totally moving from one place to another? They are in their fixed place. See, wave is moving, particles are moving perpendicularly, but particles are in their same position. Understood this transverse wave clearly now? Understood transverse waves clearly? So what is this device called as? What's the name? You can actually play with it when you are stressed. What is it called as? What's that? They'll ask for exam, huh? What is it? What's that? You can't write slinky. What's that? Slinky, good. That's a slinky. Huh. That same practical is given there. Activity 4.2. Apparatus. A slinky, a few pieces of ribbon. 5 pieces of ribbon at several places. We didn't tie ribbon, we tied a rubber band. Place the slinky on the table. My hand was the table. On the table and shake it left and right. Observe how each pieces of rubber, each pieces of ribbon moves. Each pieces of ribbon moves. Okay, so same practice. Same practice. Finally, we can represent this a transverse wave using a graph, Lamai. You can represent a transverse wave using a graph. I'll draw and show. You can represent a transverse wave using a graph. Now, this is a transverse wave. There go particles move up, particles move down, particles are moving up, particles are moving down. You can draw it using a graph. This is a transverse wave. For example, this is a water wave. Let's take water wave. This is water wave, transverse wave, water wave. In this, each and every point here, we have particles. Each and every point here, we have particles. How are the particles going to move? Listen, how are the particles going to move? Particles here will try to come down. Particles there tries to come down. Particles here try to move up. There you go. Particles there try to move up. Again, particles here try to move down. Particles here tries to move up. Listen very carefully. Eh? Particles here try to move down. Particles here try to move up. Now you need to think. Practically think. When these particles try to come down, next second what will happen to the wave? This part of the wave goes down, this part of the wave up, this part down, this part up. Can you understand the propagation here? This part of the wave down, this part of the wave up, this part of the wave down, this part of the wave up. That means this is trying to propagate. See, this down, up, this propagates. That is transverse wave propagates. See, particles are trying to move down, this part up, this part down, this part up. That way, particles are going to, and that's the way how the wave propagates. Clear? Understood the motion of the particles there? Yes. Clear. Two more special points here. Listen. maximum point in a wave. This is the maximum point. Maximum point in a wave is called as crest. Nevilamai crest. Maximum point is called as what? Crest. Maximum point of a wave is crest. So this is a crest. This is a crest. This is also crest. Maximum point of a wave is crest. And minimum point in a wave. Minimum point in a wave is called Nevilamai trough. Minimum point is called as what? Trough. So this is a trough. This is a trough. Then you all tell me how many crests are there in this wave? I'll allow you all to unmute. How many crests are there?
3.
3.
Three crests. How many troughs are there?
2.
2 troughs are there.
2.
How many crests?
3.
3 crests. How many troughs?
3.
How many troughs? 1, 2, 3 troughs. 3 troughs, 3 crests. 3 troughs, 3 crests. Okay. So that is given there. That is given. Same picture is given. The wave is there. Here the particles are trying to move down. Here the particles are trying to move up. Highest point is crest. Lowest point is. That's it. Transverse waves are done. Any doubts from transverse waves? Any doubts from transverse wave? All clear? All clear. Now we're going to longitudinal wave. Now we're going to, there you go, longitudinal wave. Now going to longitudinal wave. Again, drop your pens. All drop your pens. Sit properly. All sit properly. Eyes on the screen. Ears on the speakers. Eyes on screen, ears on speaker. Okay. Longitudinal wave. Longitudinal wave is also a type of mechanical wave. That means longitudinal wave also require a medium to travel. They also need a medium to travel. That means in that medium, there will be particles. There you go. Particles are there. These are the particles in that medium. Those are the particles. Now let's take wave is traveling in this direction. This is the direction of motion of wave. This is the direction of motion of wave. Direction of motion of wave. That's the direction of motion of wave. Wave is traveling in that direction. What is the direction of motion of particles here? Particles are going to move front and back like that. Particles move front and back. There you go. Particles are moving front and back. Particles are moving front and back. Particles move front and back. Can you see? Direction of motion of the wave here is parallel to the direction of motion of particles here. Direction of motion of wave is parallel to the direction of motion of particles. Particles particles and wave are traveling parallel to each other. So what's the key word for longitudinal wave? Parallel. Transverse wave, what's the key word? Perpendicular. Longitudinal wave, what's the key word? So what is this longitudinal wave means? If the direction of motion of the wave is parallel to the direction of motion of particles, it is longitudinal wave. If the direction of motion of the wave is parallel to the direction of motion of the particle, longitudinal wave. If the direction of motion of particles is perpendicular to the direction of motion of the wave, that is transverse wave. So perpendicular is transverse, parallel is longitude. Clear? Got it? Clear?
Yes, sir.
Yes.
Yes, sir.
Yes. Right. One more point. One more point. Now, if you take transverse wave only propagates in surfaces of solids and surfaces of liquids. But longitudinal waves are not like that. Longitudinal waves can propagate through solids, liquids, and gases. In all those three medium, longitudinal waves can propagate. It can propagate through solid, as well as through liquid, as well as through solid, liquid, as well as through all those three can propagate. Understand the differences. Transverse wave only through surfaces of solid and surfaces of liquid. Longitudinal wave, solid, liquid, gases, all those three it can propagate. Okay. Ehinam, go to the tute lamai. Go to the tute. Under longitudinal wave, write down. Under longitudinal wave, write down. If the direction of write like this. If the particle motion if the particle motion is parallel is parallel to the direction of motion of wave, to the direction of motion of wave, to the direction of motion of wave, it is longitudinal wave. It is longitudinal wave. It is longitudinal wave. It is longitudinal wave. Again, one more time I will tell. If the motion of particles is parallel to the direction of motion of wave, it is longitudinal wave. Tell me the example. We already wrote it. What's the example?
Sound wave. Sound wave.
Perfect. Sound wave. Sound wave. Right there, sound wave. Example, sound wave. Next, that point is given, propagate through solid and gases. Underline or highlight that point. Propagate through solid, liquid, and gases. Now, Hari. I have a question for y'all now. I have a question for y'all. Think and answer. Huh? Think and answer. Sound produced by a guitar. Listen to the words I'm using. Sounds produced by a guitar. Transverse wave, the longitudinal wave.
Transverse wave.
Longitudinal wave.
Longitudinal wave.
Longitudinal wave.
Longitudinal wave.
Longitudinal wave.
Both.
Hurry, mixture of answers are coming. I'll have some more questions and ask that question again. Sound produced by King's Aya. Tell me.
Longitudinal.
Longitudinal wave.
Longitudinal wave.
Longitudinal wave. Sound produced by a speaker.
Longitudinal
Longitudinal wave.
Longitudinal.
Sound produced at a Maluka day.
Longitudinal wave.
Wave.
Sound produced by a drum.
Longitudinal wave.
Can every sound is longitudinal? No? Now tell me, sound of a musical instrument.
Longitudinal.
Longitudinal.
Sound of a guitar.
Longitudinal wave.
Longitudinal wave.
Longitudinal wave. Then you will ask me, sir, then what the transverse wave part? Lamai, that is motion of the string only. String's motion is only transverse. String's motion is only transverse. How the string is going to move? Only that motion is transverse. From that, the sound that is coming out is longitudinal. Keep that in mind. Only the string. If you look at the string, how the string moves. Now, this is the string. How the string moves. That is transverse. From that, the sound produced sound is longitudinal. Keep that in mind. The motion of the string is transverse. Sound produced there is longitude. Any sound is longitudinal. Keep that in mind. Okay. Next question. Ultrasound. Transverse or longitudinal?
Longitudinal.
Longitudinal. Ultra. What is ultrasound? If the sound's frequency is more than 20,000 hertz, it's ultrasound. Don't worry, we'll learn about it. That's also longitudinal. Infrasound. The frequency is less than 20 hertz. That's also longitudinal. Right. Any sound, longitudinal. Keep that in mind. Then you all tell me, can sound propagate in vacuum?
No.
No. Because it is a mechanical wave. It needs a medium to propagate. No medium, no propagation. Why no propagation? Think practically. This longitudinal wave, in that particles are moving front and behind. So particles is a must. Particles are needed. If particles are not there, can that wave propagate? No. Same with the transverse wave. In transverse wave also, particles are showing a motion. See? Particles are moving. See, particles are moving. If particles are not moving, they can't propagate. So particles is a requirement for both transverse waves and longitudinal wave. No particle, no motion there. That means there be a medium for this wave to propagate. No medium, no propagation. So in vacuum, any kind of mechanical wave cannot propagate. Okay, vacuum means space. So in space, that is vacuum. No, any mechanical wave can propagate. Hurry. Now in your tute, we didn't draw this. Go to that box there. Go to that box. Now draw there. In that box, draw there this diagram. Direction of motion of particles are parallel to the direction of motion of wave. Meanwhile, any doubts, ask and clarify. What is vacuum? Vacuum is So sir, sound wave produced the unable to propagate. Nani? Sound wave is propagating. Wave is propagating. Only particles are not moving from one place to another. Wave is moving. See, wave is going. In vacuum, you are asking. Yes. In that case, of course, yes. So sound wave produced are unable to propagate. So does that energy just remain in the exact place as it is produced in vacuum? Yes. That is correct. When does physical class happen in Candy? At what time? Candy class is on Sunday tomorrow, 12:30 to 3 p.m. What is infrared waves? We will discuss about it. Tell me a trick to score for mole units. Do questions. So in longitudinal wave, do particles move along the wave? Along the wave, it moves front and back. Not that it totally moves from one place to another. What is your regular time for online class? From today onwards, this will be our online class time. However, on Sunday, 12:30 to 3, Candid class will be also live stream. So, sir, done. Tell me done, eh? How much hours should we study per day? It depends. I recommend minimum, if you have not started, at least start with 1 hour. If you are not at all started. Instead of just waiting at least 1 hour per day, would do something. Okay. Okay. No? Hurry. Now, those who are asking how to join, Mehimailamai, I'll put the link to the group as well. I'll put the link to the group as well. Actually, today I'm not at all well. My voice is fully gone. So class will be done via the Faraday website. I have put the link through that link also you can get the class. Otherwise, you would just visit www.faradayeducation.com. Now, those who wanted to continue the Saturday class, you need to purchase the interactive Saturday class. Huh? Interactive Saturday class. And those who wanted to continue the class on Sunday, purchase the Sunday class. Only for this month, Saturday class people are given access to Sunday as well. Because Sunday we have 2 more sections to finish. No mixtures or old past paper question we'll have to finish 1958, you know. Those papers we need to finish those paper question. In the only this month, those who purchase Saturday class given access to Sunday. Maybe next month onwards, if you purchase Saturday, you should stick only to Saturday. At the last moment, don't message me and tell, sir, I have a wedding tomorrow. Can I change to Sunday? Right? Saturday na Saturday, Sunday na Sunday. You have to continue. Saturday class is the interactive class. Sunday class is going to be live stream of the physical class. Those are the differences. Okay, now you all have an idea on how this interactive class proceeds. We talk. You can unmute and ask questions. We ask questions. I ask questions. my interactive class goes. In physical class, that part is missing. That's the difference there. Hari? Going back here. Going back there. Here also, we have a small practical with Slinky. We can study about the way using a Slinky again. Again, I'll take my Slinky. Again, the Slinky is taken. Table is there. On the table, Slinky is kept. On the table, Slinky is kept. Now we are going to learn about longitudinal waves. What I do, I move it this way. Can you see the wave motion there? Can you see wave is moving from this finger to this finger? Look very carefully and now don't think of anything else. See? Look very carefully. Can you see the wave is moving? Can you see? This is longitudinal wave. Wave is moving from this finger to that finger. Front and backwards particles are moving. Front and back particles are moving. One more thing, see, when this wave moves, see, when I press it front, a compression is created. See, very carefully, see, a compression is created. Can you see a compression there? See, all these wires get bunched up. Can you see that? A compression is created. When I move the slinky front, again see very carefully, when I move the slinky front, a compression. Look very carefully. A compression is created. They all get bunched up. All these wires get bunched up. A compression is created. Compression. So when they get bunched up, a compression is created. And when I pull it behind, can you see they all spread away? Can you see these wires are spreading away? When I pull it behind, wires are spreading away. See? When I pull it behind, wires are spreading away. So when I move it front, they get compressed, bunched up. When I move it behind, they spread away. You call it rarefaction. So by compression and rarefaction, longitudinal wave propagates. See? Compression, rarefaction, compression, rarefaction, compression, rarefaction, compression, rarefaction, compression, rarefaction. That is very good. So by compressions and rarefactions only. So by compressions and rarefactions only, this longitudinal wave propagates. Compression, rarefaction, compression, rarefaction, compression, rarefaction, compression. Got it? Got it. So this is the slinky. This is the slinky. They get compressed when I press it front. They move away when I take it away. They get compressed when I move it front. They move away when I take it away. These are compression. These are rarefaction. So keep in mind, longitudinal waves propagate by compressions and rarefactions. Compressions and rarefactions. That means sound wave propagates by compressions and rarefactions. Compressions and rarefactions. Clear? Clear? Okay, no? Will the particle move from one place to another? Will the particle totally move from one place to another? I'll allow you to unmute. Will particles move totally from one place to another? Yes or no?
No.
No. Particles does not. That same practical is given there. Apparatus
can you
slinky, a
repeat
piece of
that?
ribbon. Slinky, a piece of ribbon. Place the slinky on a table and fix one end. Tie a ribbon on one coil and move free ends of the slinky forward and backward. When the free ends is pushed forward, when the free ends are forward, what is created? When the free ends are pushed forward, the coils near the end are bunched up. This is called what? Compression. They get bunched up. It is called compression. It is called compression. When the free ends are pulled back, the coils will stretch out. This is called rarefaction. Yes, rarefaction. See, the compression, this is rarefaction. So by creating compressions and rarefaction, we send longitudinal. Okay. Now going to the questions. Who is going to be the volunteer? Right. Amna Fazlan. Wait. Yeah, now you can unmute. Amna Fazlan. Good
Yes,
evening.
sir. Good evening, sir.
Yeah. Amna, you understood the things until now?
Yes, sir.
Yes. Okay, Amna. Then tell me, mechanical waves are divided into two. Give me a second.
Mechanical waves are divided into two as transverse waves and longitudinal waves.
Longitudinal waves. Very good. Now we'll go to longitude. First, we'll go to transverse wave. What's the keyword you should remember in transverse wave?
Perpendicular.
Perpendicular. What is the keyword you should remember in longitudinal wave?
Parallel.
Parallel. Tell me an example for transverse wave.
Water wave.
Water. Example for longitudinal wave.
Sound wave.
What's the example?
Sound wave.
Sound wave. Very good. Then you tell me sound wave. Sound wave. It propagates by creating what and what in the atmosphere?
Compression and rarefaction.
Compression and rarefaction. When particles come closer, that is called as?
Compression.
When particles move further away, it is called as?
Rarefaction.
Rarefaction. Perfect. Thank you.
Thank you.
Okay. A small point is there about that vibration. You all were also asking then what is vibration, Gigi? Now listen, will you? In your science, sometimes even in your musical room, musical instrument set, there's a special device called as tuning fork. You would have heard about it. Tuning fork. Tuning fork. A tuning fork has a stem, you call this as the stem, and two arms. These are the arms. Arms. Okay. Two arms are there, and a stem is. What you can do using a tuning fork? Take the tuning fork from the stem, hit it on a rubber stamp, it makes that ping, that sound. You take it, you hit it on a rubber stamp, it makes a sound like this. Keep your ears away, and those are wearing earphones. Those are wearing earphones, keep your ears away. Heard it. Heard it. So that is the exact sound that a tuning fork makes. You hit it on a rubber stamp. Ting. That kind of a sound will be heard. Now, once when you do that, you slowly keep your finger nearby that. When you keep your finger nearby that, what you will feel? You feel like the arm is coming, touching your fingers and going, isn't it? You don't need a tuning fork. You hit on a small bottle or something, keep your finger there and keep. You can feel that there's a small, touching sensation there. You keep your finger, you can feel that there is a small touching sensation, right? That surface comes, touches your fingers and goes, touches your fingers and goes. You can feel that sensation. That sensation is called as the vibration. What is that sensation? Vibration. Front and back fast motion of a certain object is vibration. Remember, sound is produced by vibration. That's why when you hit this tuning fork, it vibrates and make that tin sound. You ring a school bell, bell will vibrate. That is why that ting sound is heard. How am I producing my sound? My vocal cords are vibrated. By vibrations only, I'm making a sound there. When I tap on a table or something, that will vibrate. From that vibration only sound is produced. So remember, sound is produced by vibration. How sound is produced? Vibration. Okay. Now we'll read that part. Found a tuning fork and touch one of its two arms with your finger. You will sense a small vibration in your fingertip. The reason for this is the alternative contacts and removal of tuning fork arm with your finger. It touches and goes. The back and forth motion in arm of the tuning fork are known as vibration. We can hear sound through the waves generated by such vibration. Such waves that cause the sensation of hearing are known as sound waves. Sound wave generated in air are another example for longitudinal. Those are all longitudinal. So remember, sound is generated by vibration. It's propagated by longitudinal waves. Finally, to have this transverse wave and longitudinal wave part, I'll give a small table. Transverse wave, longitudinal wave. Transverse wave, longitudinal wave. What are the similarities and differences between transverse wave and longitudinal wave? We all know, just we are reminding the things. Transverse wave require a medium. Longitudinal wave also require a medium. Both are mechanical waves. So both need a medium. Require a medium. Require a medium. Longitudinal waves also, there you go, require a medium. Next. What can you tell about the motion of the particles transverse wave? Motion of the particles are perpendicular to the direction of motion of wave. Motion of particles perpendicular to the direction of motion of wave. On the other hand, longitudinal wave. On the other hand, longitudinal wave. Longitudinal wave, motion of particles are parallel to the direction of motion of wave. Motion of particles are parallel to the direction of motion of wave. Next, medium of propagation. Transverse wave propagates through surfaces of solid and liquid. Surfaces of solid and liquid. What about longitudinal waves? Propagates through solid, liquid, and gases. All those things. Okay. Can you write this in the table given there? Transverse wave, longitudinal wave differences. Quickly write. Once done, tell me done. Tingala work. Yes, Mariam, you have a question? No. Hmm. Once done, tell me done. Eh? Finish. The recording will provided the online classes. Online classes usually recording is provided. Now here, of course, we have the live. No? Live will remain. I didn't record it separately. Okay, no. With that, all the waves can be mechanical waves part is over. Now we are going on to physical quantities associated with wave motion. Physical quantities associated with wave motion. Sorry. Physical quantities associated with wave motion. Now this interactive class, to make it productive, today is the first day. No? Slowly only developments will be added into it. Now slowly what we will be doing is now classes from 7:30 to 10. After 10, after the class is over, we'll be doing a MCQ paper about 5 questions, 10 questions, simple MCQ paper. I'll be selecting you again as volunteer. Not the same person every week. I'll be selecting. You will have to answer the paper. Answer me the paper. On that time, you'll have to answer me the paper. Timing කරලා we'll be checking that. That will be implemented by about third week. Still, this is the first week. No, now only you have started unmute and start talking. After that, fear is gone down. After that, all those things goes down. So what we'll do is through the online thing, we'll be doing papers, live papers, live papers. You'll have to unmute. You have to tell the answers. MCQ question, structured essay questions also slowly will move on. Will be doing like that. Hurry. That's how this interactive class slowly processes. So final at the end of the day, it's not the teacher is doing the class, it's child has to do the class. To that extent, we can develop it. That kind of a planning is done. So initially, my plan is to make you all unmute, talk, be comfortable with the environment. Slowly, we are going to develop it. A stage where you don't feel like online class. It's a physical class. Step higher in the physical class, because sometimes even in physical class you can't ask any doubt or a fear is there. A fear එක respect theater. Good questions. එහෙම theater we are going to develop it. Okay. ඒකයි plan එක. Right. So physical quantity, that is after 10 until 10 the class will proceed. Because even in my theory classes, after the class, students stay, they ask questions, solve their doubts, and only go. So you should also get that chance. Everything that a physical student gets, you also should get that. එතකොට එහෙම doubt නැහැ කියලා කිව්වෝ. I will put out into your mind and I question. That's the plan. After 10, another about half an hour, නැත්තම් 15 minutes වගේ we'll take. We'll do paper, we'll ask. 15 minutes හරි half an hour හරි. එහෙම. That proceeds that. Now already 2 hours go. Did you feel 2 hours? Is it sleepy?
No, sir.
Nah. Him knowing this thing. Yeah. Hurry. Physical quantities associated with wave motion. Physical quantities associated with wave motion. Listen very carefully. Yeah? Physical quantities associated with wave motion. So learn, listen. Now, when you wave, there are some quantities that are associated with the motion of the wave. Those quantities show some variation with the wave. What was variation? are given. What we learn under quantities associated with wave motion. I know you didn't understand the words I used here. This word, and I will understand that part. Listen, will you? When you take a wave, there are some quantities that show some variation with wave. What are the quantities that shows variation with the wave? Time. Time is a quantity that shows a variation with the wave. Distance. It's a quantity that shows variation with the wave. That means, for example, now for example, see Slinky, this wave, that is one single wave. What is it? Slinky, this is one single wave. You can see this one single wave. It takes some time for this wave to go, isn't it? See, it takes some time for this wave to go. Is there a problem with the voice? Is there a problem with the voice? No? So this wave, again see, if I take this wave, if I take the wave, see, it takes some time for this wave to go. Several milliseconds are going. Taking some time for this wave to go, see. Taking some time for this wave to go. So this wave shows a variation with the time. Wave shows a variation with the time, see. Take some time for this wave to go, shows a variation with the time. As well as wave shows a variation with the distance. You see, this wave is moving from this hand to this hand. So it has a distance to travel. It has a distance to travel. So it shows some variation with the distance as well. So wave shows variation with time as well as with the distance. See, with time also there is a variation. Some time is taking for the wave to go. With time there is a variation as well as with distance there is a variation. So wave shows variation with time as well as it shows variation with distance. We can talk about those two things separately. First, we will consider the variation that a wave shows with distance. That variation can be drawn using a graph. See, will you? Using a graph, we can draw that. Using a graph, we can draw. Using a graph, you can draw. Look very carefully. Now, this is a graph. My y-axis is going to be the displacement of the particle. If you take the particle, particles are going to show some displacement. Displacement of the particle is y-axis. X-axis is going to be the distance that the wave travels. Distance that the wave travels. Listen very carefully. X-axis is the distance. Y-axis is the displacement. I draw a wave now. Now this is a wave. That's a wave. That's a wave. Can you see? This wave is traveling a certain distance. Wave is traveling a certain distance. As well as because it's moving up, it's moving down, it's showing a displacement. So what I have done here is displacement versus distance graph. Wave is traveling this much of a distance. Particles are moving this much of displacement. The wave is traveling this much of distance. Particles are showing this much of displacement. So I have drawn the displacement versus distance graph for this wave motion. Okay. What are the important physical quantities here? Listen very carefully. What are the important physical quantities here? Listen. Samai, this is going to be one single wave. What is this? One single wave. This is one wave. That is one wave. This what? One wave. One single wave is also called as one oscillation. So this is one oscillation, nothing. This is one wave. Then you all tell me all together how many waves are there? Altogether, how many waves are there?
2.5.
Sir.
2 waves.
When I
2.5.
perfect. So altogether, 2.5 waves here. You all now tell me. How many waves are there?
3 waves.
3 waves.
There are 3 waves here. So this is one single here. One single also called as oscillation. One wave is also called as one oscillation. Right. Now listen.
Sir, the voice is not clear.
Now check.
Can you increase the volume, please?
Now clear, no?
Now it's clear.
Hurry. So this is one single wave. Next one, you all know. You all tell me, Lamai. Highest point in a wave. We already talked about it. Called as
Crest.
crest. Perfect. Highest point in a wave is crest. Then you all tell me how many crests are there?
3.
Perfect. 3 crests are there. 3 crests are there. Next. Lowest point in a wave is lowest point in a wave is
3 crest.
how many troughs are there?
2.
How many troughs? Perfect. 2 troughs are there. So maximum point in a wave is crest. 3 crests are there. Minimum point in a wave is trough. 2 troughs are there. Okay. Next, listen. Maximum displacement of the particle. What's the maximum displacement of the particle? This. This is the maximum displacement of the particle. See, particle is moving upward. This is the maximum displacement. Maximum displacement of the particle is called as amplitude. What is it called as? Amplitude. Maximum displacement of a particle is called as amplitude. Maximum displacement is amplitude. Maximum displacement, there you go, amplitude. So this is amplitude. Now your turn. Y'all tell me. Y'all tell me. Wave A, wave B. Which one's amplitude is greater?
A.
Amplitude is greater. I maximum displacement of the particle is amplitude. Here more displacement is there. Here very less displacement is there. So amplitude less in B, amplitude more in A. So maximum displacement of the particle is amplitude. That is amplitude. Next. The distance between, listen, I'm using the distance between one particle closest next particle that shows the same state of motion. One part closest next particle that shows the same state of motion. Listen very carefully. The distance between one particle that shows the same motion. See, this is a particle.
Sir, your voice is talking.
Sir, voice is not clear.
I think when I go there only, there's a problem.
Yes, sir.
Now, okay. When I come here,
Now okay, sir.
Clear.
Now it's okay, sir. Now okay, sir. It's okay.
now okay. एक नहीं. Alright. Listen, I'll do from here. Distance between particle and close particle that shows the same state of motion. Again, listen to the words I'm using. The distance between one particle closest next particle that shows the same state of motion is wavelength. That means, let's take this particle. Closest next particle that shows the same state of motion. What's the closest next particle that shows the same motion? To this particle, closest next particle that shows the same state of motion is Y. Now, after this particle, wave is up. After this particle also, wave is up. Before this particle, wave is down. Before this particle also, wave is down. So, if you take these two particles, show the same state of motion, correct? No? Now, this particle and this particle, are they showing same state of motion? No. This particle and that particle shows the same state of motion. Distance between them, distance between these two particles, that distance is called as wavelength. What is that distance called as? Wavelength. You give a symbol to that, Greek symbol, lambda. Lambda is the Greek term, lambda. Greek symbol. Wavelength, Greek symbol, lambda. Greek symbol, lambda. So what is wavelength? Distance between a particle and closest next particle that shows the same state of motion. Wavelength. In other terms, I tell it, distance between a crust and the closest next crust. Correct? Crest, sorry. The distance between crest and the closest next crest. Now, these two particles shows the same state of motion. So, that's going to be wavelength. Or even I can tell distance between a trough and the closest next trough. Consecutive troughs. Distance between two consecutive troughs. Even that can be told as wavelength. Makes sense to see? Here the particle, same state of motion. Between them the length, that length is wavelength. So, distance between a particle and the closest next particle. In other terms, I can tell the distance between two consecutive crests or two consecutive troughs. Wavelength. In very simple terms, if I tell, what is wavelength? Length of a wave. See? Length of a wave. This is one single wave. This one's length. Wavelength. Makes sense, no? Length of a wave. Wavelength. Length of a wave. Length of a wave. Now, some students misunderstand and think when I tell wavelength, wavelength, They think this length from there going down, going up, may length එක. ඒක වැරදි. That is nothing. That's not wavelength. This linear length. Linear is wavelength. The linear length is the wavelength. Length of a wave. Not this length, not the curved length. The linear length is wavelength. So length of one single wavelength. Length of one single wave. Now a question. Ten meters. What is the wavelength of this wave?
5.
5 meters.
5.
5 meters. 5 meters.
5 meters.
5.
5 meters.
Perfect. Full length is 10 meter. There you have two waves. Wavelength is one wave's length. One wave. Two waves are 10 meters now. One wave is 5 meters. So wavelength is 5 meters. Wavelength is 5 meters. Wavelength is 5 meters. Okay. So those are the main physical quantities. So length of one single wave is wavelength. Again, we drew displacement versus distance graph. This is one single wave. One wave is also called as one oscillation. This is one wave, also called as one oscillation. Maximum point is crest, minimum point is trough.
Is not clear.
Maximum displacement is amplitude. The distance between one particle and the closest next particle that shows the same state of motion is wavelength. You mark it using lambda. Okay, no? Now take your tube. Under that physical quantities associated with wave motion. In that first box there, I want you all to draw this graph. Shatta Vatagala draw. Once done, will be done. The amplitude means the maximum displacement of the particle. The particle is moving maximum upward. This length, amplitude. Okay. All right, we'll read that part for us to read. Go to the next page. Crest. What is crest? Maximum point of a wave. Trough. What is trough? Minimum point of a wave. Amplitude. Maximum displacement shown by the particle taking part in the wave. Maximum displacement shown by the particle taking part in the wave is amplitude. Next. Wavelength. Distance between one particle and closest next particle taking part in the wave motion having the same state of motion is known as wavelength. The distance between these two particles, that is the distance between two consecutive troughs or crests. Distance between two consecutive crests or trough, wavelength. Okay. Any doubts up to there? Before we wrap up the session? Any doubts up to there?
No, sir.
No, sir.
No, sir.
Sir.
All clear. Ask some questions. Who is going to volunteer?
Sir, there are two boxes in the PDF, right?
Yeah, second box is for next.
Excuse me, sir.
Question session. Who's going to unmute? Raise hand. Right. Zainab Anis. Wait, I'll allow unmute feature. Zainab Anis.
Yes, sir.
Can you hear me?
Yes, I can hear you.
Yes. Good evening, Zainab.
Good evening, sir.
You're from?
I am from Kandy.
Right. Zainab, you understood the things today?
Yes, I understood.
And ready to answer some questions?
Yes, sir.
Yes, perfect. Zainab, you tell me. Wave A, wave B. Which one's amplitude is more?
Wave B.
Wave B, perfect. Wave B amplitude is more. Look at the waves. Wave A, wave B. Which one's wavelength is more? Wavelength.
Wave A.
Wave A, perfect. Why? This one's wave is little bit long. Now think and answer me. No need to panic. Just a normal question. This full length is 8 meters. Full length 8 meters. I want you to tell me the amplitude of this wave.
4 meters.
Perfect. Full length 8 meters, then maximum displacement is 4 meters. Yeah, those are the main questions that they will ask. Very good. Thank you, Zainab.
Thank you, sir.
The main types of questions they will ask. Remaining some physical quantities are there for us. Periodic time, frequency, speed. With that physical quantity is over. After that, electromagnetic wave and sound. That's it. The lesson will be over. That's it. The lesson will be over. Okay. And now we have come to the end. If you are continuing now, hereafter YouTube live won't be given. Hari, YouTube live won't be given. In the YouTube live, I also will have to join through the website to our Zoom. Plus, this point keep in mind. Now, in Faraday website, when you all are creating an account, give a proper Gmail address there. With that same Gmail address, have your Zoom account also. Because once when you click the link through Faraday, unless you have the Gmail added to the Faraday in your Zoom, it doesn't allow you to join. So whatever the Zoom account that you have, the Gmail that you have in your Zoom account, same Gmail you give it to the Faraday also. So in the website, if you when you are purchasing, fill the proper name you can do. Every day, then Saturday night we will continue at this time. Usually finishes at 10, have everything until 10:15, 10:30 again. We'll be doing some additional work also starting from the third week. And tomorrow online class, please join. Our normal online students, tomorrow's online class, please join because we have salt extraction to finish off plus the past paper questions. In the tomorrow online as well as next week online, Sunday also continue. Later you can change it to one single day. Arine, any doubt? Any clarification? What you all think, Lamai? Interactive class ek honda hai.
Yes, sir.
Thank
Okay,
you,
good.
sir.
Perfect, no?
Hundai, sir.
Good. So your suggestions to cut me send me as a WhatsApp message.
Sorry.
Right. Me your suggestion me send me as a WhatsApp message. Plus this video will remain in YouTube. In YouTube as a comment also suggestions and go. So according to suggestion we can add
So, what
because this
about
is
the
fully
upcoming classes? Will they be in the YouTube?
up the stream through Zoom. Only through Zoom it will be streamed. He might classes with I put a tutorial on how to join the class to the group as well. Then on two things we should do because it's fully focused on your end. You should feel like you are sitting in a physical class, individual, not even as a group class. Like individual class, you should have the feeling. Even planning. Your end the suggestion, what are the things? Are lagging prashna tikanang me technical issues no. Those things will be sorted out. I think today it is lagging because this area today some places power cuts were there. Might be that's the reason. Hari magi transmitter also dancing up and down. Hari I'll use another transmitter. So lagging prashna tika nang ඒව ටික හදා ගන්න පුළුවන්. අනිත් ඒව ටික. Right. Teaching wise what are the improvement we should do ඒ වගේ. හරි practicals ටිකත් how ඒව ටික your suggestions you can give. හරි එන්න. Come to the end. With this I finish off our wave session first day theory class. Okay. I'll meet you all again. Then tomorrow people I'll meet you all tomorrow. Other people I'll meet next week. Okay. Bye.
Thank you, sir. Good night.
Thank you.
Thanks, sir.
Thank you, sir. Goodbye.
Okay. Bye. Bye. Bye.
Thank you, sir.
Thank you, sir.
Okay. Bye. 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 Bye.
Thank you, sir. Bye.
Okay. Bye.
Good night, sir.
Good night.